Hello, hi, my name is Hassan Anifowose, and today I will be presenting our research titled BIM LOD plus Virtual Reality using Game Engine for Visualization in Architectural and Construction Education. I am with Dr. Wei Yan and Dr. Manish Dixit. I'm a PhD student in the Department of Architecture, and Dr. Wei Yan is a professor of architecture. Dr. Manish Dixit is an associate professor of construction science. Now, let's talk about what actually inspired us on this research. We're looking at state of the art technology, and we're looking at how BIM and virtual reality can be applied in design practice and design education, in design education particularly. So let's talk about how adoption of technology, has happened. So in big firms, BIM is almost universally used. However, in a research by the AIA Firm Survey report from 2018, 67% of large firms are adopting virtual reality, and only 27% of mid-sized firms are showing some form of VR penetration into their firm culture. On the side of education, it is a little bit different. It's low because there are so many factors hindering adoption. Part of these factors could be cost, maintenance, physical discomfort, and of course, poor instructional design because it requires a whole lot to properly develop virtual reality learning applications. So, um, what also inspired us was our current methods, of architectural learning. So here is a picture that was taken just before COVID struck, and these were my students' models. At that time, we were learning about precedence, and we had to move from the classrooms to Zoom. And one thing we realized was there was quite a lot of difficulties in that shift because learning in architecture is mostly tactile. The students can touch, they can feel, they can observe, and then they have this perception of space. But Zoom didn't offer us any of that. We only had screen sharing, and that was really difficult to pass across the message. The ability to try, to try things was not present. So we decided to start looking at how do we, start making changes in our design and construction education methods. So right now, our students learn with two-dimensional architectural plans and elevations, 3D generated models, 3D computer generated models, physical models, and of course, they make models by cutting and assembling models, and also they study precedent photographs, and if they can, they of course visit places. But of course, all these have changed since COVID, and of course, right now, planning a visit to a president is an entirely difficult process due to the travel restrictions by COVID. Now, let's look at what we started thinking about. How can gaming be introduced into BIM and education? How do we think that gaming could help us, improve the process for people? I mean, achieve autonomous motivation to learn. That's something. Now, the possible benefits that BIM has provided for VR is that it provides the foundation for visual and spatial cognition. So if we take BIM into VR, we have a higher chance of success at improving learning and interaction in our virtual environment. So, but on the other hand, we must also acknowledge the fact that AR and VR for education is difficult, based on the complexity of content generation. It's hard, it's not very easy. And if you look at this, you will see that education is still falling far behind in the spectrum of research for AR and VR. Now, we started focusing on VR particularly, and part of the reasons why VR has not been fully deployed for education in a lot of places is that it's difficult to generate the design, to make the designs of these virtual environments, and the virtual environments for learning is as important as the content you're trying to teach. So one other thing we found out was that, according to literature, if the game is too challenging, people don't want to play it because they can't progress, and if it's too easy, they don't want to come back because they are no longer interested. And we found a couple of papers that actually focus on the appraisal of VR and AR in terms of design education. and we got to learn and adopt some of the framework that were previously prescribed. So what are the research questions that we started asking? We started looking at the best practices for content design. What are these practices? How do we improve on engagement and student learning with BIM and VR? And also, does VR combined with BIM contribute to effective learning at all if we use level of development, which means we go from one simple level to a more difficult level, and that is where the gamification process comes in. Now, we started designing a prototype to experiment with what we're thinking. And here basically is the process through which we went about our prototype development. So we split our research into mostly three stages and future work. And for the pre-game stage, we made all the assets and components that we needed to set up the virtual environment and learning content. Then we proceeded to develop the in-game experience, which means the users could step into the game, explore the scenes, go to a practice area, and go to an exercise area to use the game. That is mostly featured on the player. And the post-game stage is where we will be collecting feedback based on our demonstrations, and we will be using this feedback to improve the game until we are able to make it into an open source game that anybody could start feeding their content into and can easily publish. At that stage, I've been collecting data and learning about how user experience, behavior, interaction, and effective learning is actually happening inside our BIM VR game. Now, what inspired how we worked? We looked at the Lego system. The Lego is very basic geometry that could help anybody create anything. And we started looking for online resources, and Mechabricks was the perfect one. So we took out assets from Mechabricks and we used them to develop low level of development of the components in the building. Now, we also went ahead to develop the abstract concepts such that they can be visually seen and understood. Concepts like full geometry, structure, lighting, and circulation were developed, and we also went ahead and made a real scale precedent that people could explore. We used light baking techniques, custom scripts, and locomotion, and made sure that we tested this pretty well. So, in the game, we had three stages. The first stage is where the users explore the building and learn with the abstract geometry. The second stage is where they go into the assembly task and they create the building. They recreate the building with an LOD 200 level. And the last stage is the part where they assemble the building with an LOD 300 game objects component. So we had an insert video here, which we found from the National Trust for Historic Preservation, and we used that video to facilitate the learning within the environment. Here is a quick snippet of the gameplay.
Wood and glass and cloth and marble. It is a painting, it is a sculpture. The curtains, the draperies are so much a part of that.
Every bar stock member, every angle, every screw is treated with the same amount of attention to detail.
So the students interact with the abstract concepts while they explore the building. They understand the design pedagogy, they understand the architect's intent in designing the building, and this way they're able to grasp a lot more, and with the video playing they can understand a lot more about the building, and also they can proceed to a stage where with the LOD 200 components they can rebuild or attempt to rebuild the building they've just learned about, just using basic geometry, trying to replicate the structure components, the access points and everything like that that they've seen and learned from. Now, if we go to the next stage where they actually start the assembly.
Achievement, and it belongs to the middle of the 20th century as one of the iconic buildings of that century, which is the century of modernism.
Now, the object spawning system enables us to generate objects in the scene without loading the game too much. So they can decide how many objects they need to achieve the required composition. And of course, making this a multiplayer game where the professor is also in the game and can make corrections and give them comments based on what they're recreating We believe that this would facilitate a lot of learning. So, what are the findings from our feedback, from the feedback we received from demonstration? Let's look at the video content narrative actually helped user to understand much better, and the object spawning system improved hardware performance. We realized that we did not load our hardware and it ran smoothly with frames per second, and also the snap to position, snap to angle, grid, also improved interaction and overall engagement, because it's easy for people to play the game, as against if it was too difficult to even place the objects, then the learning would be hampered. Now, if we look at content development results, we realize that modeling with rhinoceros was great for geometry development. However, if you're looking at retaining data, the OBJ format is not the best. But in our case, we didn't need the data in the components, so the OBJ format gave us very great results for the file exchange between Rhino, Revit, and Unity. Now, for unbaked textures, we realized that textures, when not baked, actually improved our game, and our big lighting also increased realism. So, what's our future work going to look like? We want to experiment with new sample groups, students and professors. We want to get feedback based on all the things we've done, and we're going to collect data to actually see how they are performing in the game based on their level of progression, how long it's taking them to play the game, how frustrated they are, or how easy they're learning. And also, we're going to be collecting assessments in forms of interviews and surveys after the data, after the experiment. So our result analysis are going to help us to identify content development pros and cons, and also measure the level of effective learning which occurred. We're happy to answer your questions. Thank you very much for listening.